Good morning friends, my name is Mr. Reddy Patil. In last video we discussed how to draw the SFD BMD. Now we will solve the numericals on the simply supported beam without the UDL. So as per the given diagram, uh, we know that at the support points means A and B points reaction will be generated RA and RB. So first we have to find RA and RB with the analytical conditions. So first condition will be the summation of f of y equal to 0. There are three analytical conditions: summation of f of y equal to 0, summation of f of x equal to 0, and summation of moment about reference point equal to 0. So we have to use only two analytical conditions. Reason: because there is only two unknowns. So we are using first condition, summation of f of y equal to 0. Y means forces acting in the y direction. Summation of f of x means summation of algebraic summation of forces acting in the x axis. So all the forces in this diagram are acting in the y axis. So we are using the analytical condition, summation of f of y equal to 0. So sign convention will be upward going forces are positive and downward going forces will be negative. So we can directly write down RA upward going forces are RA plus RB, and downward going forces 40 plus 40 plus 40, that is 120. Okay, so now this give this equation number 1 to this step. Give the equation number 1, RA plus RB. Okay, next is the summation of moment about reference point. Now A, C, D, E, B are all our reference point, but which one we have to select? Select the reference point which is unknown. RA means A and B, values at A and B are unknown, and select the point which is at the left hand side means A equal to 0, 0 equal to. Now the clockwise forces and clockwise moment will be positive and anti-clockwise moment will be negative. Clockwise will be positive and anti-clockwise will be negative. Now uh, mark the all the distances from the reference point. Okay, RA is passing through the reference point. So force multiplied by distance. Force is RA and its distance is 0. So it will be 0. So we are not writing it. So next is a 40 acting at a distance 1. Next is a 40 acting at a distance 2. Next is a 40 acting at a distance 3.5. Next is a RB acting at a distance 5. Okay, so we applied the definition of moment, means force. It is a product of force and perpendicular distance. Force multiplied by 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 perpendicular distance. Now we have to apply the sign convention. If the force is rotating in clockwise direction, it will be positive, and if it is in anti-clockwise direction, it will be the negative. So all the forces are rotating about the reference points. 40 kilonewton is rotating clockwise, so it will be the positive. 40 kilonewton also rotating clockwise about the A point, so it will be the positive 40 kilonewton. Again it is rotating clockwise, so write down the positive sign. And rb is rotating anti-clockwise, so write down the minus sign convention. Now after calculation, it will be the 5 rb equal to 260. rb will be 52 kilonewton. Now we have the already equation number 1. Put the value of rb into equation number 1, and after simplification 120 minus 52, we will get the value of the ra value will be the 68 kilonewton. So in the SFD and BMD numericals, first step will be to find out the reactions ra and rb with the help of the analytical conditions. Now we have to find the SFD values. As per the diagram, first we must write the naming sequence. So here are two types of concepts are there to solve the SFD. So first identify if in numerical there is only point load or point load and UDLs. Okay, so if only their point loads, so how to solve I will explain later. So first step is how to write the name. So while writing the naming, so basic concept of left and right is applied about the reference points. So A, C, D, E, B are the reference points or key points. They are the inbuilt key points. Do not generate the new key points while solving the numericals. Okay, so apply the concept of left and right. If point is A, then write the SF at left of A and SF at right of A. Now point C is there. Write down SF at left of C and SF at right of C. For point D, write down the SF at left of D and SF at right of D. For point E, write down SF at left of E and SF at right of E. And for point B, write down the SF at left of B and SF at right of B. This is a standard method to solve the SFD and BMD. But we observe here that number of steps are tens. 10 steps are there. If so, I already told, if identify the numerical. If there any UDL is there, then apply this concept. If in numerical there is any UDL, I will explain also later with the example. If any UDL is there in the numerical, apply this concept. Okay, but no UDL. If in the numerical there is a no UDL, apply the concept as I am writing now. SF at A, SF at C, SF at D, SF at E, and SF at B. So number of steps are directly reduced in the second method. Okay, so first step is to identify the numerical with UDL or without UDL. If single UDL is also given there, then apply this concept, left hand concept, apply this left and right concept. If in the numerical there is no UDL, then apply this concept. If the in the numerical no UDL, then apply this concept, apply this method. So standard method will be this. So how to solve this? So in this I already explained in some videos, we have to move from the left hand to right hand, and sign convention will be upward going forces will be positive and downward going forces will be the negative. So left of a point and left of a point is there, and left point of the a. So towards the left of a there is a no force, means no force means value will be 0. Now right of a point a is there, and right of a means here we are observing point ra, we are observing the force ra. Force ra will be 68 kilonewton, and it is going upward. Upward means upward sign convention, for the upward sign convention will be the plus 68 kilonewton. Now SF at left of C, left of C point means here, means here, means we are only observing RA and it is going upward. Upward going means sign convention for that is positive, means plus 68 kilonewton. Next SF at right of C. Right of B means this is a C point, and right of C means here. We are observing here two forces, 68 kilonewton and 48 kilonewton. 68 kilonewton is going upward, means positive, and 40 kilonewton is going downward, means negative. Downward forces are negative and upward are positive. The value will be 28 kilonewton. Now left of D point is here, and left of D here. Also we are observing the two forces only, RA going upward and RB 40 kilonewton is going downward. So plus 68 minus 40 equal to 28 kilonewton. Next right of D. Right of D means here. Here we are observing 68 kilonewton going upward, means positive, 40 kilonewton at C point going downward, it's negative, and at point D also 40 kilonewton, it's also going downward, means it negative. How to write? Plus 68 minus 40 minus 40 equal to, answer will be the minus 12 kilonewton. Next is the left of E. Left of E we also observing the 68 kilonewton at A point, 40 kilonewton at C point going downward, and at point D 40 kilonewton going downward. Okay, so write down, answer will be minus 12 kilonewton. Now right of E. Right of E means here what we are observing, 68 kilonewton again, and at CDE point 40 kilonewtons are going downward. So plus 68 minus 40 minus 40 minus 40 kilonewton, answer will be minus 60 kilonewton. Next is the B point, sorry. At the B point left of B we are also observing the same forces, 68 and 3 times at CDE, at CDE points 40 kilonewton. So answer will be the same, which is a minus 60 kilonewton. So right of B means here. So at the right of B, how to write? Plus 68 minus 40 minus 40 minus 40 and plus 52. So answer will be the 0 here. So this is the standard method to solve the SFD. Apply the concept of left and right. But now we are going to solve with the second method, which is simpler because here steps are step 10 step and increases the calculations. So we have to reduce the calculations here. Except at A means consider up to the point A only. But this concept is applied only for or when there is a no UDL in the numerical. Okay, when no UDL in the numerical, only point loads are acting. So SAP at A means consider the forces up to A points only. Consider the forces up to point A. So we are observing only 68 kilonewton, which is going upward. 68 kilonewton. Next, SAP at C. Observe only forces up to point C. Do not look at backward. Do not consider the backward forces. Consider only means SAP at C means only observe this much or consider this much for the calculation. SAP at D means consider the beam this much only. Do not look backward. SAP at E means consider the this much only, and SAP at B means consider the whole beam. So SAP at C means consider the forces up to point C only. So 68 kilonewton going upward and 40 kilonewton going downward. So plus 68 minus 40 equal to plus 12. Okay, so answer will be 28 kilonewton. SAP at D, consider the forces up to point D means plus 68 minus 40 minus 40. Answer will be minus 12 kilonewton. SAP at E, plus 68 minus 40 minus 40 minus 40 up to point E means like this: 68 40, 68 plus 40 downward negative, going 40 going downward negative, and this 40 also going downward, it is a negative. So answer will be here one correction is there in SFAT. This answer is minus 52. This answer is a minus 52, calculation mistake. Okay, so SFAT E is a minus 52 kilonewton. While solving the numerical, when you applying this concept, this concept, always write the previous point answer at the last point. Means previous point for the what will be the answer for the SAP at B means previous point answer minus 52 kilonewton. If we calculate, answer will get the 0. While drawing the SFD, I will show why we return the directly previous point answer here. Okay, so we are drawing the SFD now. So first draw the 0 line, and on this 0 line mark the key points as it is. So as per this calculations, at a point two values are there, 0 and plus 68 is there. Plus 68. This is a zero line. Above above the zero line all positive values, and below the zero line all negative values are there. At a point first value is 0, and first other value is a plus 68. At C point there are two values are there, plus 68 and 28. Plus 68 and 28 is there. Also at D point two values are there, 28 plus 28 and minus 12. Plus 28 and minus 12. At E point also two values are there, minus 12 and minus 52. Minus 12 and minus 52. Here we also have to change 52. Okay. At B point also we have two values. This is a 52 and other answer is a 0. So previously, in the previous video, we understand the how to draw the SFD. In the numericals all point loads are there, so SFD will be the horizontal straight line will be there. So A to B, sorry, A to C, draw the this is a height. A to C is a horizontal line, C to D is a horizontal line, because in the numerical C to D is a no variation of the loading. Same as D to E, there is no variation of the loading. Same A to B, there is a no variation of loading. So connect these lines. You can write the values here. Plus 68 kilonewton. This is a 28 kilonewton. This is a 12 kilonewton. Minus, this is a minus 52 kilonewton, and this value is 0. So this is a plus, this is a minus. So this is the method to draw the SFD. Okay, as per this diagram we have drawn the SFD. But we also draw the SFD as per these calculations. So first is a zero line, mark the key points. At A, what is the value? At A, value is a 68. At C, value will be the 28. So this is a 28. At D, value will be the minus 12, and at E, value will be the minus 52. So as per the rule type of the types of loading, so A to C, there is no loading. So draw the horizontal line. Again C to D, there is a only point load is acting, no variation of the loading. So draw the horizontal line. And D to E point, there is also no variation of the loading. Draw the horizontal line. Connect here. Again, this is a minus 52. Now at the point E, now understand here, this is the main point. At the E point we got the answer minus 2, minus 52. So as per the calculation, if we do the calculation, value at the b is 0, value at the last point right of the b is 0. But from here we can't directly join this line, because if we join this line, it will be the inclined straight line, it will be the inclined straight line. And SFD, and in the SFD, as per this rule, in the SFD, when in SFD, when will be the inclined line? When there will be the UDL, when there will be the UDL. But as per our numerical, there will be the no variation of loading, only point loads are acting. So first we have to move horizontal, because E to B there is a no loading. So first we have to move horizontal, and then we have to reach to the 0 point. So here we have written directly minus 52, because at E point we got the minus 52. So first we have to draw the reach to the B point at the minus 52, and then we have to reach to the 0. Okay, so here, while last point, must all student must take the precautions how to write. Okay, concepts are maybe vary in the overhang beam. So I am telling this because these are the minimum steps are there. So this concept I am telling for only for the simply supported beam and without the UDL. So when will there will be the overhang beam, there will be the little bit changes in the concept, and there will be the little bit changes in the cantilever beam. Okay, so this will be the positive and this will be the negative. So I explain the both methods here. So apply the second method when there will be the no UDL in the numerical. Okay, thank you very much.